Alright, here we are in video number 5 in our series on polynomials. We talked about how to divide polynomials using long division yesterday. I want to show you a strategy today called synthetic division, which you may like better than long division. We'll see today. Our first problem for the day you might recognize as the same problem we started the long division video with. Dividing x cubed minus 9x squared plus 26x plus 28 by x minus 2. Yesterday we set this up like a traditional long division problem, went through those steps, and then practiced it a lot in class today. So in synthetic division, I think the hardest part about long division is you've got to deal with all those variables as you go through all the steps. You're dividing variables, you're multiplying variables, you're subtracting variables. The advantage that some think synthetic division has is that it takes all of the variables and gets rid of them and then brings those variables back at the end. And I'll show you how this works. Here's how you set up a synthetic division problem. On the first line of your paper there, if you've got lined notebook paper, on the first line, we're going to rewrite all the coefficients of this polynomial, right? So for x cubed, since that's 1x cubed, we're going to write a 1. Negative 9x squared. 26, 28. These are all the coefficients of our polynomial that we're dividing, right? Now over to the left of those coefficients, put a box, just a small box, small enough that you only have to fit one number in there. The number that goes in that box comes from this x minus 2, but it's not negative 2, it's a positive 2. It's actually the opposite of this number that goes in this box. All right, so here we have coefficients. These are the coefficients of our polynomial. Here we have the opposite of this number, comes over here and goes in the box. All right. Notice we're not dealing with the x cubes, the x squareds, the x's. We're just dealing with the numbers, just with the coefficients, and here just with the last constant term of the x minus 2, just a positive 2 there instead. Okay. On your paper, now that you've got these coefficients written down, leave a blank line. We're going to put some numbers here, but we're not ready to do that yet. But underline that line. So leave this blank, then draw a line underneath there. And then we're going to put numbers down below that line you drew as well. So some space for numbers here and some space for numbers here. Basically, we're creating a grid of numbers here that will give us the answer to this division problem. All right, now that we've got it set up, here's how you do synthetic division. We start with the first coefficient, which is a 1 in this case. We just bring that coefficient down below the line that you drew. So we just have a 1 that goes there now. Now you take that 1, you multiply it by the number that's in the box. Do 1 times 2 here is 2. Put that 2 here in your grid. And then you're going to add those two numbers in the column. You do negative 9 plus 2 to get negative 7. We repeat that process over and over. We have a new number down here, a negative 7 below the line. We're going to multiply that by the number that's in the box. Negative 7 times 2, negative 14. And then we're going to add 26 plus a negative 14 gives us 12. And then one more time, take that 12 times the 2 that's in the box, 24, and then we add here, and that would give us a 52. It's always multiplying and adding. Drop that first number down. We multiply and add. Multiply and add. Multiply and add. So now we have a grid of numbers, and from that grid we're going to take the answer to this division problem. The numbers below the line are kind of a coded way of writing the answer to this division problem. These numbers have the answer to this division problem in them. We just have to kind of break the code and get the variables back in. All right, so let's go back and think about the original problem. The original problem asked us to do an x to the third divided by an x. And if we would have done this by long division, that would have been our first step to figure out how many times x goes into x to the third. We know that's x squared, right? That x squared is the variable, is the degree of our first number here. So this 1 stands for 1x squared. This is 1x squared. And then we count down in degrees. So this -7 is a -7x. This plus 12, now this 12 is just plus 12. So we have x squared minus 7x plus 12. Now we've got a leftover number here. Why do you think we have a leftover number? Well, that's the remainder. Just like we had remainders yesterday when we did long division. We're going to treat that remainder the same way we treated it yesterday, by putting it over what we divided by, the x minus 2. And so here is our answer using synthetic division. If you flip back and look at yesterday's notes, you'll notice that's the exact same answer as we did this with long division. We're just looking at a different technique to divide here. So that's synthetic division. Put all your coefficients in a row, the opposite of this number in this box over here. Drop down the first coefficient, and then you are multiplying and adding all the way through the problem. And then bringing back your variables at the end to get your solution. Okay? So that's an example of synthetic division. I have another one here to try. If you're feeling confident at this point, before we do this one, you can go ahead and try this on your own. If you'd like to wait and set it up together and then pause it and try it on your own, you can. Okay, so you do whatever you feel comfortable with here. If you want to set this up with me, the coefficients go in our row here. 1, 7, 6, -24. Remember, the opposite of this number goes into a box over here. So now we're putting a -4 in the box. Okay? Blank line, blank line. Okay? Drop that first coefficient down. Multiply that number by what's in the box. 1 times a -4. Add down. 7 plus a -4 is 3. Repeat. 3 times a -4. And then we add. -6 times -4. And then we add. Right? Drop that first coefficient down, always multiplying by the number in the box and then adding down the column until we fill out our grid. These numbers represent our answer. We've got x to the third divided by x. It's going to be an x squared, so that 1 stands for 1x squared. Plus a 3x minus 6. We've got a 0 there, so no remainder at all. So we don't have to write that. Our answer is just x squared plus 3x minus 6. And that's our solution. And that's all there is to synthetic division. Right? Less work on the page, less to write out, getting rid of those variables, bringing those variables back. Now at this point, now that you've seen synthetic division, we spent a whole day yesterday in class doing long division, which is a struggle for a lot of us. Now that you've seen synthetic division, you may be like, hey, wait a minute, why did you make me do long division? I like synthetic division a lot easier. It's shorter. I don't have this many steps to go. I'm not dealing with all those variables and all. So why did you put me through the long division process? Do you just hate me? I did not make you do long division because I hate you. I might hate you, but that's not why I made you do long division. Synthetic division is great. I love synthetic division. I use it whenever I can. The problem is you can't use synthetic division with everything. You can only use synthetic division if you're dividing by just x minus a number or just x plus a number. So the two examples we did today are great. If you remember yesterday on the video, we divided by x squared plus 3. You can't do synthetic division when you're dividing by an x squared term. You can't do synthetic division when you're dividing by, let's say, 2x plus 3. Synthetic division only works if it's x plus something or x minus something, the basic division problem. So long division will still be something that you have to use, even if you prefer synthetic. So that's why we did long division first. So if you like long division better, you can use long division for everything. Just the majority of people generally, once they get used to setting up the grid, they prefer synthetic division. I want to do one more example with you today, just to show you something to be careful of when you're setting up your grid for synthetic division. Now the last problem you see there has a few things that are different than the ones we've done so far. Now, as I go to set this up, you'll notice in the box over here, we're going to have a positive 1, so we're dividing by x minus 1, all right? We're going to put the coefficients there and then an empty line. I'm going to set this up. Looking carefully at that problem, you'll notice that something's missing in this polynomial. What do you see that's missing in that polynomial? We're missing one of the degrees. We're missing an x cubed, an x to the 3rd power. It's important to account for that when you set up your grid. All right? So then we've got a 2 as our first coefficient here, for 2x to the 4th. I'm going to put that here. But since there are no x cubes, I need a 0 in here like as a placeholder. That 0's there because we have no x cubes in our expression. Then negative 6x squared plus 5x plus 3. But anytime you are missing a term, every degree should be accounted for. So since I'm missing an x to the 3rd, a cubic term there, I need to put a 0 in there to account for that. Otherwise, when you get your answer at the end, you get your numbers at the end, you won't have enough numbers to finish your answer, right? Once you make sure you get it set up correctly, everything works the same. Drop down your first coefficient, multiply by what's in the box, and add. Multiply and add. Multiply and add. Multiply and add, like that. These numbers represent our answer. Now here, notice we've got an x to the 4th divided by an x. Right? X to the 4th divided by x would be an x to the 3rd. So this 2 stands for 2x to the 3rd, 2x cubed. Then we count down 2x squared minus 4x plus 1. We do have a remainder this time, so we'll say plus 4 over the x minus 1 that we divided by. So make sure you account for anything that's missing. Anytime you've got a degree that's missing, you want to put that in your grid to make sure that you've got enough coefficients for your answer. That's how synthetic division works. We'll practice synthetic division tomorrow, and then we'll start to look at how we can use these division techniques to start solving some of these polynomials. Okay, see you tomorrow.